Good afternoon. My name is India Banks, and I am the project manager in the Licensing and Regulatory Infrastructure branch at the NRC responsible for this meeting. Today's observation hybrid pre-application public meeting is for SMR Holtec to discuss updates to its soil structure interaction methodology, corresponding white paper, and for the NRC technical staff to discuss and ask questions. Following the open session, we will have a closed session to discuss any proprietary information with the staff. We welcome the members of the public, including our international guests from the Japanese Nuclear Regulation Authority, who are observing this pre-application meeting today. After the end of the business portion of the meeting, we will provide an opportunity to the members of the public observing the meeting to make comments on the topic discussed or ask questions to the NRC staff. Pre-application engagements like this meeting provide an opportunity for early discussions with a potential applicant to offer licensing guidance and to identify potential licensing issues early in the licensing process. The NRC has not received an application for the SMR 160 design at this point and is not evaluating any final design information. Before we begin with opening remarks and introductions, a few reminders. 1. Please put your microphone on mute if you are not speaking. 2. Please state your name and organization before asking a question or making a comment. And then finally, please only use the meeting chat for logistics information. Please do not provide your comment in the chat. I now invite Michelle Hayes, Chief of the Licensing and Regulatory Infrastructure branch, to give opening remarks on behalf of the NRC staff, followed by Andrew Brenner, Director of SMR 160 Licensing, to provide his opening remarks.
Thank you, India. So I'm Michelle Hayes. I'm the branch chief responsible for licensing Holtec's SMR reactor. I want to thank everybody for attending today, Holtec, the staff, our Japanese guest, and all the public, members of the public who've called in. Thank you. I do appreciate Holtec's willingness to engage in pre-application with us. It's an important precursor for us to understand what is going to be submitted, to get to know the design, and to help provide some guidance and feedback. I just wanted to clarify that we won't be making any regulatory decisions at today's meeting. We'll just be discussing the presentation material that's been provided.
Thank you, Michelle. Andrew, I'll turn the floor over to you.
Thanks, India, and thank you, Michelle. And again, I'd like to reiterate, I appreciate everyone taking the time today to meet with Holtec and discuss this topic with us. We appreciate all our opportunities to engage with the NRC in pre-application space, and definitely value the feedback that you all provide as we try to work towards our eventual construction permit application submittal, and hopefully use these meetings to help inform our submittals to make sure that we're providing the NRC the information you all need to make that safety evaluation of our design. I'd also like to just note that this is a follow-on meeting from a meeting that we had roughly a year ago at this point. And we're excited to share some progress that we've made, in addition to kind of walk through our methodology as well, since it is a new and unique methodology that hasn't been used in an application previously for soil structure interactions analysis. So definitely encourage the staff to ask any questions along the way as they come up, and looking forward to a good meeting. So thank you.
I will now call on NRC staff to introduce themselves. Once again, my name is India Banks. I'm a project manager. I will first call on the tech staff in the room, and then I will go to the staff that are on Teams. So you can start.
Atay Star, NRC, structural engineer.
Omid Ghosh, NRC, structural engineering branch.
Okay. Next, Sunwoo Park. If you want to introduce yourself.
Yes, the Sunwoo Park, NRC with the APRC branch.
Kamal, if you want to introduce yourself next.
Yeah, Kamal Manoli, Senior Technical Advisor for Structural Mechanics, Division of Engineering.
Laurel Bauer.
Good afternoon, Laurel Bauer. I'm the branch chief for the Structural, Geotechnical, and Seismic Engineering branch. Thank you.
Ian Singh.
Yeah, my name's Ian Sang. I'm the chief of the Structural, Civil, and Geotechnical Engineering branch in NRR. Amit and Atta are here from my branch.
Next, we'll have Shil Pasavada.
Hey, good afternoon. This is Shil Pasavada. I'm a branch chief in the Division of Risk Assessment.
Thank you. Next, Thomas Weaver. Can you introduce yourself, please? You're on mute.
Thank you. Yes, Thomas Weaver. I'm in the Office of Research in the Structural, Geotechnical, and Seismic Engineering branch.
Thank you. Next, Kim.
Hi, good afternoon. My name is Chin Pan. I'm a risk analyst from RDRA APOB. I'm supporting, I'm observing here. Thank you.
Thank you. If that's everyone from the tech staff, if not, feel free to unmute yourself and introduce yourself from the NRC staff on the call. If not, I'll turn it over to Andrew to introduce the whole tech staff.
Yes, so again, I'm Andrew Brenner. I'm the Director of Licensing for the SMR project with Holtec. I see on the phone with us today Justin Hawkins, the Managing Director for the Holtec project, in addition to Amdashan Babardi, who's the lead for our civil structural design. With Amdashan, I see Anshul Yadal as a civil analyst, in addition to John Zai. John's going to lead the discussion today. He's also part of the civil structural design team. Also, Clark Shurtleff is part of the licensing group as well under me. I believe that's everyone from Holtec's side. If I missed anyone, feel free to unmute and let us know.
Okay, that's the last call for introductions. And thank you. I will now invite Andrew to introduce the SMR. Yes. Now you can proceed with the slide. Michelle, you can put that on the screen and we'll start the presentation portion of the meeting.
All right, so I'll just turn it over right to John Zai. I'll note Chuck Bullard's also listed in this presentation. He's our Director of Engineering for our Corporate Engineering Division at Holtec. He unfortunately couldn't make it today, so it will just be John presenting. So John, I'll turn it over to you to walk us through the slides.
Okay, thank you, Andrew. Before the presentation, I think we still have two members from SC Solutions who are consulting, provide consulting service to Holtec. I would like them to introduce themselves.
Thanks, John. Yes, this is Pay Monteroni with SC Solutions, based in San Francisco Bay Area. We provide specialty seismic assessment for commercial and Department of Energy nuclear space.
And this is Natalie Dolgorakis, also with SC Solutions.
Okay, thank you. So this presentation, let me start with the first page. Andrew, next one. So this is the agenda of this presentation. We already finished the introduction part. We'll go over the purpose and the outcome, and then kind of discuss a little bit about the background and the previous discussions with NRC, followed by overview of Holtec's SMR seismic methodology, and then we will present some preliminary results, and we will have some questions, and then we end it with open forum. Next slide. For this part, we completed. Next one. So the purpose of this meeting, we want to provide a high-level overview of the soil structure interaction methodology for the Holtec SMR, and we will not want to discuss some preliminary results and our future plans. So we expect to get some feedbacks from NRC staff on the presentation material and any potential risk areas and the gaps in the methodology. By the way, we do receive comments from NRC staff this Monday, and we have done some review of the comments. We will provide our answers officially later on. Next, please. So the methodology has been discussed with NRC. I mean, starting the previous meeting about 1 year ago, we introduced or propose a method which is not conventional. It's a nonlinear soil model involved in the SSI modeling and analysis, and this is also a time domain approach as opposed to the conventional frequency domain calculations. Following that meeting, we received NRC's feedback, and our understanding is NRC staff has a high-level understanding of our proposed method, and at that point, we don't see any immediate concerns from the staff. We also noted that NRC point out this is a first of kind of a review because of the nonlinear and the time domain approach. NRC will have additional questions regarding this approach. Next, please. So let me start with that the design basis seismic ground motion of this SMR design. We did some research on the US nuclear power plant sites, and we come up with a reasonable seismic design response spectrum for soil sites. And the table lists the seismic design response spectrum in the vertical and the horizontal directions. So we have like a ZPA of 0.4 Gs, and we think that this response spectrum can cover most candidate soil sites for our SMR design. Next, please. And this slide shows the soil profiles and some soil properties we choose. So the soil profile we follow that direction from SRP 3.71. We have the best estimate, lower bound, and upper bound soil profiles to account for the uncertainties of the soil properties. This is it's overall it's like total 170 feet soil profile, and at different depths we expect the soil property changes. So we use the 93 EPRI document to take account of those variations with depths. Basically, those are the modulus degradation and the damping ratio variations with the soil depths. Next, please. This slides just provide an overview of the proposed SSI analysis method. As I said earlier, this is a time domain and a nonlinear approach, which is different from the conventional frequency domain approach. So we will consider the global soil behavior as a linear material, which is based on the strain compatible soil properties obtained from Schick 1D analysis. We expect nonlinear soil behavior may be significant in the region next to the adjacent to the embedded structure, and where the soil strain is typically larger than other regions of the soil. The structures are all modeled by linear elastic materials. We introduce geometric nonlinearity at the interfaces between the soil and the embedded structures. Next slide. So to instill confidence in this proposed method, we are going to do some validation work that includes first the soil material models. So we identified two material models for the soil. The first one is material 232 in the DINA material library, which is the equivalent linear elastic material model. So that model will be used to simulate the global behavior of the soil. The second model is a nonlinear inelastic material model, which is material 79. It can capture relatively large energy dissipation in soil area adjacent to the embedded structures. So to validate those soil models, we expect to demonstrate that the first linear model can reasonably match Schick 1D seismic response analysis results. And for validating the second one, we're going to demonstrate that this material model can absorb the same amount of energy as predicted by a theoretical solution at the element level. Next slide, please. So the second validation focus on the time domain analysis results. So we want to use this validation to demonstrate that the results are aligned with a conventional approach solution. So the L-Steiner model of this validation, we will make it the linear model. So the soil and the structure nodes are shared, are bonded together. So there's no sliding or gapping, no geometric nonlinearity in that air standard model. And then we will have a SASE solution for the same problem. And so both are linear analysis. We'll try to demonstrate that both approach will yield very similar results. So this is as a demonstration of the SSI solutions are defendable using that material 232 for soil. And after that, we will introduce a nonlinearity by defining the contact between the embedded structure and the soil, so that the structure and the soil can separate it and can move relative to each other. And that will be demonstrated by running for like a higher seismic intensity to show that the difference between the DINA solution and the SASE solution will become more significant as seismic intensity increases. Next slide, please. So now I'm going to report the progress after the last meeting. We have done some analysis. The first thing is we developed the input acceleration time history based on the seismic design response spectrum.
John, sorry to interrupt. I think there's someone from the staff who has a question.
Okay.
Yes, this is Sonopark. I wonder if Holtec is intending it to be an interactive presentation, or you want staff to wait until conclusion of the presentation to ask a question?
Well, I would prefer to stop me anytime so that we can.
Okay. Yeah. Okay. I have a question on a previous slide. Could you go back one step further? I mean, behind. Yeah, there. Yeah, validation is talked about here, and actually one of the steps written question concerns the validation and the verification of Holtec's this new methodology. And here in the first bullet talks about the validation will be performed using a representative SSI model. So I wonder what scope or the level of the effort or detail Holtec is considering for validation and the verification. I guess Holtec is considering at least more than a single problem, even though it is here just one particular SSI problem will be used as a validation problem. But so could you elaborate on Holtec's plan, the validation and the verification plan for this methodology?
Okay. So we consider the two levels of validations, verifications. The first is the material model part, which is discussed in the previous slide. The second one is the SSI solution. For this specific slide, our plan is to come up with a simple but representative SSI model. And we will run that for various earthquake intensities and just demonstrated we get consistent result with SESI if the earthquake is not too significant, because we don't expect that the SESI result will match the Ersteiner when the nonlinear arity becomes too significant. So that's why in the last bullet here, we will show the difference of the two solutions as seismic intensity increases.
Okay, thank you. Yeah, thank you for your explanation. Yeah, at least if I share a view on behalf of the staff, is that we expect a fairly extensive set of test metrics to be used for validation and verification, encompassing a combination of different input and the different structural configuration. Yeah, so basically covering a variety of the combinations, and then we will have more confidence that this new methodology can be applied to not just one single specific set of the single set of parameters, but the methodology can be applied to more versatile set of a problem.
Yeah, I think if I mean, let me summarize this. I think we can come up with a matrix like we have different soil profiles and different earthquake intensities, but we're not going to well, currently don't plan to run different like geometries, different structures. Just come up with a representative structure with deep embedment in soil, because that's kind of what our SMR design is going to look like, and that's the plan I can think of at this point.
All right. Yeah, thank you.
Okay, let's move to the next slide. I think previous one, we didn't finish that. Yeah, we generated seven sets of acceleration time histories based on the response spectrum, which is consistent with SRP 3.7.1 requirements for nonlinear analysis. And we also run 1D solution, 1D response, seismic response using Shake. So we get the strain compatible properties for the soil for all the three soil profiles. And also we obtain that input motion for SSI analysis, which is at the bottom of the soil column. And so those are going to be used in the SSI model as an input motion. Next slide. And we have made some progress on modeling of the design. At the time we started this work, we only have a preliminary SMR 160 design. It's a single unit SMR. So the model we develop based on that preliminary design includes soil, seismic structures, and adjacent and non-seismic structures. Those are containment enclosure structure, including the containment structure and the internal structure of the containment, reactor auxiliary building, control building, radioactive waste building, turbine building, and annex building. We use solid elements to model soil and thick civil structures components. We also use as solid elements to model water in the annular reservoir and in the spent fuel pool. That water model is a simple water model and has no shear capacity. We use shear and thick shear elements to model the structural walls and the slabs, and we use thin shear elements to model that the equipment and some structures. Beam elements are used to model structural beams and the columns, also steel structures and certain equipment. Finally, we use mass elements to account for the masses of equipment of significant weight. Next slide, please.
Before we move to the next slide, we have a question.
Hi, John. This is Amit Ghosh from the Structural Engineering branch. Can you elaborate on your second bullet, the solid elements doing to model the soil and civil structural components as well as fluid water? Is what kind of elements you have been used, big elements, and how you model the water part? Can you elaborate a little bit more?
Okay, the solid elements for soil, we use like 8-node solid elements, and the material model, as I mentioned, we plan to use material 232 and the material 79, but they all take the solid element shape. And the civil structures, also majority of those thick structures will use solid elements. And for the walls, there will be shear elements. For the water, considered in that SSI model, we use a simple fluid material model available in Dyna, but we don't intend to model that sloshing effects. We consider that's a secondary for the SSI analysis, and so that's a plan for utilizing solid elements in the model.
Can you explain the basis, like the sloshing will not be a big one because in a water pool, that's the biggest one, the fluid, and if you have a solid element, both, so it's not, the elements cannot go cross over the another one. But when you have a sloshing, that material is crossing the element boundary. I'm not very clear on that part. Could you please elaborate?
Yeah, the model we plan to use for water is not capable of simulating sloshing. So it's basically we account for the inertial effects in the SSI model. That's the plan. I mean, and I see a couple of applications. I don't see any of those kind of account for the sloshing in the model. Maybe NRC staff has some suggestions for us here. We'll welcome any comments on that part.
I'd also like to add, this is Anveshan from Holtec. Also like to add that there's two water bodies in the model. One is the annular reservoir, which is a fairly narrow structure with water inside it. It's almost 60+ feet of water height, but only about 10 feet wide. So the sloshing effect there should not be significant. And in the spent fuel pool, we will be performing a follow-up seismic structural qualification of the spent fuel pool, considering the hydrodynamic effects and all the applicable effects of water. So the purpose of the SSI analysis is to obtain the seismic response at different locations, elevations within the overall model, and then use that input in some cases to inform more refined, localized models to evaluate those structures. So including the spent fuel pool.
Thank
Yeah.
you.
Yeah, and I would just caution that, we're in pre-application space and we can provide feedback, but we can't offer guidance or
Yeah.
consulting or anything. So just make that clear.
I have a follow-up question on this. This is Altay Star in the room. If I'm not mistaken, the walls of the major structural elements are SC walls. Is that correct?
They're primarily reinforced concrete. In some cases, they're steel concrete composite. Yes.
So when you they're quite different from each other. So you're using the same element type for each seawall and reinforced concrete sections.
Well, it depends on the overall configuration of the structure. We could use solid elements. We could use shear elements. Like for those walls and the slabs, we use shear elements. And for the base mat, definitely solid elements. So for some containment internal structure, bulky configuration, we use solid elements.
I think that second bullet point where it notes thick civil structural components, the key there is the thick. So if they're fairly thick, only then they're represented by solid elements. If they're thinner, relatively thinner, then shell elements will be used.
Yes, and the shell elements you are using to model the SC wall characteristics.
And what is thick, what is thin in your case? Is there a limitation in the thickness? Let's say 3 feet thick. Is it a shell element or solid element?
Well, it also depends on the size of the wall. I mean, if it's a large area of a wall, definitely consider as a shell, because if you use solid elements, then you can't account for those bending flexural effects unless you like model the multiple layers. I mean, we have some finite model meshing follow these slides, so maybe we can have a better understanding of the overall meshing.
Okay, thank you.
Thank you.
And next slide, please. This picture shows the overall model of that for the SSI analysis. So we have a big soil area region to model, and all the structures considered are in the center area of this model. And this soil go all the way to the bedrock elevation. Assume that minus 170 feet. Next slide, please. Next slide.
I think
Yeah.
It's jumped probably
Yeah.
too much. But okay.
Hold on a second. Having some trouble. We're on slide. And this way.
Yeah, this is a close-up view of that SSI model. We have turbine building, CES, annex building, RWD, and the reactor auxiliary building. Next slide, please. This shows various elevations where the soil surface interact with the embedded structures. For example, -26, where that's the base of the control building. -45 is at the bottom of the RAB, and there's another step in the RAB embedded structure at -15, and the CES goes all the way down to -86. Next slide, please. This picture shows the CES overall model. This gray area is embedded in soil, and you can also see the annular reservoir between the green and that kind of reddish mesh. That's a very narrow configuration. No significant sloshing is expected, as I mentioned, explained. And this, you can see some of the internal CS structures. Next slide, please. Okay, those are the more clear view on the CS and its internal structures. We have, for example, we have beams model, the steam generator, RPV, represented by beams. The internal structure inside of that containment structure is looking like this. We have here is like spent a few pool water in the pink area, and we have 6 shell elements here to model the slabs. Okay, next slide, please. This is one view of that reactor auxiliary building. Here, this typo should be east end, and this kind of partially surrounded that the CES structure, and all those like beam elements. You can see those beam elements, and other walls or slabs are all modeled by shell elements. Next slide, please.
Are these connected to each other right now, all these buildings, or is there a gap? Like seismic gap between the buildings?
This basically shows the RAB and the CB, so they are connected by design. Yeah.
But the other large buildings, they are separated. As you noted, the seismic gap is provided, isolation gaps between other large structures.
Yeah, this picture shows another orientation looking at this RAB and the control building. So we have solid elements modeling that base mat at different elevations. Next slide, please.
I have a quick question here. Not knowing your configuration very well, and all I see is this picture. I see basement over basement. Is that just the way the picture is depicted can be seen, or that's true? Like the yellow basement at elevation -45 feet. Over that, there is a CB base mat at elevation minus 26 feet. And over that, there is a base mat, RAB base mat at minus 15. Oh, this
Yeah.
is just the way this view is.
So the question, can you repeat that?
Yes.
Not sure I follow
In
that.
this picture, I see like there are several base mats. One is yellow or yellowish RAB base mat. There is another bluish color base mat, RAB base mat. And then there is a CB base mat red. So, and they are at a different level. So they go all the way, or they just only the building footprint.
Their building footprint, basically they take their own local area to support the structure above. For example, you see that minus 15 elevation, and those like supporting above structures, but they are all connected.
Okay. But there is a basement yellow basement below the blue basement.
Yeah, I unfortunately I don't have the model that can turn around and show you that
Okay.
that the details, but it's a major base mat supporting the majority of the weight of the RAB building, and then that red one extended beyond that. The yellow one is the control building base mat, but they are also connected to the structures. They're all connected together. Yeah.
Okay. Thank you.
And all these structures are surrounded with the nonlinear mat 76 material. Is that correct?
Well, I think that the ground surface is, I mean, if you can see my pointer here,
No.
here, this elevation. So they are all surrounded by soil, as I showed in the previous soil model, where different soil surface is at different elevation that kind of match the base mat elevation. So in terms of nonlinearity at the interface, this DINA model, by defining the contact between the structure and the soil, we can capture any potential sliding, any potential gapping during the earthquake.
Including overturning?
Yes.
And can you so you'll be doing some experiments to get the properties of that contact model, the parameters for the contact model, correct?
Yeah, the major contact parameters is the friction coefficient.
What about the stiffness?
Stiffness? No, the stiffness is automatically reflecting the material model. So the stiffness is governed by the soil material model.
Doesn't contact have a stiffness because they are not smooth?
Well, there are surface to surface contact in the model. So any indentation to press certain area, and that soil will be giving and then behave and according to the material model. So it's automatically captured the local stiffness.
Thank you.
Next slide. I think we'll skip some preparatory information all the way to page 30. Oh, okay. is this a PDF?
Yes,
Okay.
Yes.
Well, if it's a PPT, we can click the button that show you the oscillation of the structure. And I embedded a video here, but we cannot do that.
we don't have the PowerPoint. I don't know if you guys want to share the PowerPoint, if somebody in Holtec has it.
Let me see. I think I have one.
We can pull it up. I can.
Let me share that. Share my screen.
Okay, stop sharing.
Public portion is at 2:30, but it can go over.
Little bit slow here.
And
My computer is not
If people
responsive.
speak if they want to, because they might want to leave at 2:30.
I can share my screen, John.
Okay.
And play that video.
I can exit it, but I don't know whether you can share
after
that.
this, after this, after you share this slide, we're going to open it up to members of the public, just in case they want to ask questions, and we can resume during the closed portion of the meeting, just because the open portion was scheduled to end at 2:30. So once this is complete, we'll open it up to members of the public to see if they want to ask a question.
Yeah, I guess I'll just comment, you have this marked as proprietary and confidential, but this is a public portion, and I believe that this was on our public slides.
So if you play that, you can notice that the oscillation of those buildings.
Yeah.
You see it? Yeah,
It's pretty subtle.
you can see it.
Yeah, we want it to be subtle. We don't want it to be drastic.
You maybe want to exaggerate the,
Yeah.
Noise.
Yeah.
Gonna start again. We'll look closer this time. Maybe.
Yeah, you can see.
Oh, okay. If you just look at one little thing.
in this direction, like this is correct.
Okay, so
Thank you, Avensha.
thank you. So at this point, we're nearing the end of the public meeting, and we will open the meeting up to public comments and questions for the staff before we have the closed portion of the meeting where we can resume the presentation. So if there's anyone else that wants to ask a question, can you please raise your hand and I will call on you?
I think we still have a few slides from page 31, which is public information. Just
Right,
wondering-
but we said the public meeting was gonna close at 2:30, so just in case people didn't
Okay.
plan to stay past 2:30, we could continue after, but we do want to give people the opportunity to speak now. And any questions from? Oh, one of you guys was a seismic guy. Any questions? Was that you? No questions?
Okay. No questions?
Okay. So.
Okay, well, I guess you can continue until, if you want to keep going, and anyone who needs to drop off can. And then we'll do the closed portion of the meeting.
Yeah, we have 5 minutes. I think I can talk through those results.
Okay, continue. Thank you.
Page 31. So I just plot 2 locations, what the acceleration looks like. This is a acceleration time history at the ground elevation inside the containment internal structure. It's at the RPV stand location. I just picked that arbitrarily. This is X direction. Next slide will be same location, but it's in a perpendicular Y direction. X
Just to
and
make
Y
sure-
are horizontal directions. So the next one will be the vertical direction time history. Next slide. And you can see the ZPA is increased a little bit to like 0.46 Gs. And next slide, please. This is
You're saying it's still on 30. Can everyone else who's on team see slide 34, or is it stuck on slide?
I see slide 34.
Okay, thank you.
Yeah, sometimes you have to log out and log back in when that happens, unfortunately.
Thank you.
this result is taken at the polar crane supported elevation. You see that ZPA increased to 0.8 Gs roughly. That's the first direction, horizontal direction. Next slide, please. Y direction is about the same ZPA. And then next one, please. That's the vertical acceleration time history. So they are all consistently increased as this is located at a pretty high elevation. Okay, next slide, please.
We have a question.
Okay, please.
Yes, this is Sonopar again. You just show the response in terms of a time history. Do you have any response in terms of response spectrum?
Oh, I didn't create that response spectrum for that time history. I can do that. I didn't spend time on that.
Okay. Yeah, that will be much better because the time history, it is difficult to interpret. Where response spectrum provides much more information, such as the frequency dependency and so on. So yeah, that should be much better.
Yeah, you're correct. And I should have spent more time on this to show more insights of that responses. Okay, thank you. So this one just shows our understanding of the limitation of linear model. We, based on the literature studies, we believe any area that soil strength go beyond 0.35%, it's better to use the nonlinear soil model. In Dyna, it's 79, material 79. So that will capture the enhanced energy dissipation, maybe a permanent soil deformation. So that's from that the plot. You can see that at the 0.3 something, your direction changes. The modulus can be quite different from the initial elastic region. Okay, next slide, please. And those are the SSR simulations we plan to carry out. So we have 3 different soil profiles. We have 7 different earthquake sets. We will start the run in 2 steps. First, we apply gravity only, so that all the initial responses can be settled for a significant simulation time for gravity load only. And then we have a full deck restart, and which capture the stresses states of various members and started around, and we provided that the transient seismic load, the seismic input motions in acceleration time history in 3 directions. The analysis will be generate the results, and we will going to average that results that's consistent with SRP 3.7.1, and then we will also develop enveloping response spectrum for in-structure responses. This is per RegGui 1.122 and SRP 3.72. Next slide, please. This is the updated design information. We come up with a standard dual units design that will be used for our application. But the methodology and the modeling approach analysis will be pretty much the same as we presented for the preliminary SMR 160 design. Next slide, please. Licensing approach. Holtec is considering submitting a license topical report that includes both SSI methodology and the results using generic inputs that are intended to bound a number of potential soil sites in the United States, including the Palisade site, which will be most likely the first application. Additional soil rock generic input parameters are also being considered for inclusion in the license topical report. Finally, the licensing topical report is currently planned for mid-2025 and is intended to be referenced in the future CPA for SMRs at the Palisade. And we also finally have a few technical questions. And hopefully we'll get the feedback from NRC staff. This is regarding the separation distance between adjacent SMR sites for the individual site installation to be considered decoupled. Is there any NRC guidance on accepted industry standard regarding structure-soil structure interaction? This is for the multi-unit sites situation. We have those questions in mind, and we hopefully get the NRC staff's feedback on that, guidance on that. The other issue is water table. What level of analysis is required with respect to water table elevation? The other one is there any NRC guidance or accepted industry standard regarding effects of water table on SSI analysis? So those are the questions we have. I think this is the final slide of this presentation.
Okay. Thank you for your presentation. I guess last call for anyone who is in the public portion of the meeting that wants to ask a question before we go to the closed portion.
I guess, India, maybe before we do that, I am curious if the NRC does have any feedback for us on some of those questions, if there is any NRC published guidance or accepted industry standards out there that they could point to that we would, could be aware of. That I would think the public may be interested in that as well, just so we would have those Session.
Somebody want to speak? No,
I don't have any recommendation. I have tons of questions, but not in the closed session.
Yeah, so this is a very new thing and
Yeah,
also,
it's a new thing.
and because it's so highly nonlinear, things can go wrong in the analysis or simulation very easily. So go step by step and then verify, validate at each step that yes, things are.
And time step.
Yes, each are, because time stepping is a very important issue in the simulation.
Yeah.
Because we have two varying stiffness material,
Yeah.
widely varied. One is a solid, one is a liquid. So the liquid will dictate the time step in the simulation.
But how would you characterize the water level in the soil? So it just that's another curve issue here.
Yes.
So that's
come from the site characterization of the hydrology. And
for these two questions, I understand that NRC, Carol, already submitted our written feedback to Holtec.
Yes.
So
I wonder. Well,
ASC4 is a good standard to do the soil structure intervention.
Yeah.
That's what we do.
So did Holtec not receive written feedback on these two questions back in August this year?
I would have to double check that. I think the only thing that we've received so far was, I guess, the questions in specific relation to the white paper, but I can double check that. Give me a couple seconds.
This is Thomas Weaver from research. I don't know about any specific industry guidance on, the effects of the water table, but just, I would just use basic soil mechanics principles to, and if water pressures are going to influence the soil behavior, then I would expect that they would affect the SSI.
A different type of material.
Okay, we just.
I guess
evaluated.
Caroline.
All right.
I'm sorry. Yeah, Caroline is back here. We are talking about the Caroline, the written feedback NRC provided to Holtec back in August
Yes,
on the
Andrew.
two questions.
Sure. Andrew, do you have that email? It was also included. I don't know. Sorry, I got kicked off and I can't reopen all the files quickly. But the feedback that we provided should have a link at the very top of the email referenced. I think it was from August 29th. Just a second, sorry. It's at the very top. India, can you read the ML number? I think Amit has it. Amit, could you read the email, the accession number?
Yes, ML 23226, A as in alpha 138. ML 23226 alpha 138.
Thank you, Amit.
Yeah, sorry. So I did type the session number in the chat. I'll see if I can pull it up from the public Adam so you guys can have a link.
Thank you, Carolyn. Thank you. For whatever reason, I'm not seeing that email right now, but I appreciate the ML. Thank you.
I sent the email. I think I sent it yesterday, but it was basically a list of the staff's questions, and at the top there's a link to the questions that Sun was referring to. Okay, I sent it on Monday.
Yeah, I see that now. I'm trying to open that up. My browser's not letting me go right through the link, but I can look it up from the NL number, so that works for me. Thank you.
And that is publicly available.
No, that was just distributed to Holtec. So
No,
I
so
said-
this is Carolyn. I'm sorry to interrupt. I did put in the chat the link to that accession number. So that accession number is the email that I sent to Andrew with the responses to the 2 questions that someone was referring to. So you should have not only the ML number in the chat, right? The ML 23226 alpha 138, but there is also a link that follows it. And that link is from the public Adams site.
Yep, I have that now, Carolyn. Thank you.
You're welcome.
Thanks.
Yeah, since this question is being talked about, if I can verbalize, you can take a look at in detail later on. Basically, STEP provided the high level, the guidance that were pretty much accepted from SRP 372. And the Holtec specifically asked a question about the acceptable separation distance for 2 units to be considered decoupled. Yeah, for that, again, the SRP does not provide a detailed, guidance that they can handle that. But one can consider like a sensitivity study involving 2 units with a varying distance and compare the resulting seismic response as a function of the separation distance, and then determine separation distance that produce negligible differences in seismic response. Then that way you can know what separation distance is needed to be able to consider 2 units independent seismically. So, again, I'm providing quite common sense type feedback in addition to our written feedback. Hopefully that makes sense to you.
Yeah, thank you. That does make sense, but it's case by case. It's like for a specific site, you may have a distance which is considered sufficient for decoupling, but that same number may be different. I mean, you may see significant coupling in a different site, at different site. So is that correct understanding? We have to do the parametric study for every application. Okay.
Yeah, that's what I was saying. Do a sensitivity or parametric study involving different separation distance, and you can run and they can then compare results with a different separation distance, and then at some point you may see the difference becomes negligible. Okay, then you can say, oh, this is a separation distance. You can declare then 2 units are seismically independent also. Yeah.
Okay. Is there any quantitative, like a definition of negligibleness? I mean, 5%, 10%, that's any numbers?
We do not communicate that threshold, and SRP also does not provide that number.
Okay.
Because again, case by case review also involve that threshold. And you can, they propose, and then we review. Instead of us prescribing any threshold.
Understood.
All right, thank you.
Thank you.
And on the water table issue, I believe Thomas shared his view, his comment a minute ago. That can be considered.
Okay, we will look into that document. Thank you.
All right. I want to thank everyone for their participation in this meeting.
Are you going to the closed?
Yes. And I wish you all a good rest of your afternoon. This now concludes the public portion of the meeting. I was going to say we could take a 5-minute break, but
Yes.
if you want to.
Yeah.
Okay. Before beginning the closed portion of the meeting to discuss the proprietary information, so I guess we will resume at 2:52.
Make it 55.
Okay, 2:55, just to make it a nice round number. And this meeting is adjourned. Thank you so much.